the fuel is mixing before the valve is opening. Yes, that is the characteristic of a port fuel injected engine. So in fact, let me just pause the video right there. So for example, Harshit, if you see here, in a port fuel injected engine, you can see that there is a large amount of, what do you call, spray parcels that are trapped inside the valve, correct? Now, this is basically very common in port fuel injected engine, and this is going to come inside the engine during the next cycle. So basically out of your injected fuel, correct? So say that you are having 100% fuel. Let us say 5% is trapped inside your port, only 95% comes in. This is during your first cycle. But then during your second cycle, this 5% will first come in. So inside your engine, you will always have 100%, and you will always have 5% in the port. So the system kind of reaches an equilibrium at that point. Okay, perfect. All right, guys. So yeah, we're almost at 1.5 hours, which is very nice. Okay, everyone. So with that, I would like to conclude the workshop. Thank you all for attending, and I hope you learned something about IC engine simulations. Now, all the participants will be receiving a certificate, a e-verified certificate for this workshop, and this certificate will be sent to you to the registered email ID. So whatever email ID that you used to pay and register for this workshop, make sure that you check your promotions and spam folder, and you will be receiving the certificate within 2 weeks. Okay. So at this point, again, thank you so much. And at this point, what I'm going to do is I'm going to be talking about a couple of courses that we have with respect to this particular, with respect to IC engines and CFD. Before that, I think looks like someone has a question. Doesn't this accumulated fuel affect valves' metallurgical properties? Not. It might. Well, the honest answer is I don't know. And the reason why I don't know is I don't think it's a huge problem, and that's why I don't know. Because if it is such a problem, then PFI engines would not exist, right? Because the fuel as it is different. It's not like you put special fuel for a PFI engine, right? So I feel like it's not a big problem. It might cause some corrosion. It might be, but I feel like that might not happen in the lifetime of an engine. MPI engines are the same as PFI. Are you talking about MPFI engines by any chance? That is a different concept. So MPFI stands for a multi-point fuel injection system, MPFI. So that means your injector, it's an injector which has multiple points, meaning it has the injector has multiple nozzles. So in this case, if I hide my embedding, you can see that I have 4 spray cones, right? These 4 spray cones are coming from the same injector. So this is a multi-point fuel injection. So how to decide the mesh size for a simulation? That's a great question. The honest and the most effective way to determine the mesh size is grid dependency test. So, you know, back when I was working for all these companies, right, what we do is we run the same engine with multiple mesh resolution. And there are some fundamental calculations that you can make. Meaning, in case of turbulence simulation, you're using a RANS method. You can calculate something called as a turbulent flame thickness, and your computational mesh size should be on that order. Similarly, in order for your spray models, your mesh size can be calculated approximately using simple calculations. And that is your starting point. So what you always do is you use the starting point and you keep on refining your mesh. So by CV, we might have a boom in IC engines in a decade. Is this the right time to choose this as a career? See, like I said, you know, companies like Toyota, General Motors are putting in a lot of money in simulating or researching engines, which means if you're still thinking about choosing it as a career, getting into IC engine simulations is never bad. Because remember this, for example, in this case, if I'm able to set this up, right, I know how to set up flow. I know how to set up turbulent flows. I know how to set up combustion. I know how to, you know, basically set up complex cases. These 3 skill sets can be used for any domain where flow is involved, which could be your gas turbines, which could be your pumps, compressors, which could be your hair handling equipment device, HVAC systems, all that stuff. So Nitin, I hope I answered your question. And Basivi, I hope your question got answered as well. What is the parameter to be of interest if spray is here for grid dependence, as you mentioned? Well, what I would do is I would look at something like liquid penetration length or vapor penetration length. So the idea is quite simple. Are you familiar about liquid penetration length, Nitin? If not, just let me know. I can kind of draw a quick chart and explain. So what you can do is you can basically perform liquid penetration studies on a vaporizing spray, a non-reacting vaporizing spray, and then you can consecutively do a grid independence test to make sure that your liquid penetration length is converging. If you can do that, then you know that that is the spray, that is the grid size you need to use, and you can have that as a standard.